First of all, just so everybody's aware, we are recording this presentation, so just to let you know. My name is Steve Sorich. I am PAC International's sales director, and we have Mike Raley. He's our INCE board certified acoustician on the call, and we have two guests today with us. We have Zach Ciambotti from Crescent Communities and Nick Block from SLR Consulting. They're going to talk about kind of the background on this. This is a case study with our RC1 Boost, and the title of this case study or this presentation is Addressing Product Availability and Cost Concerns in Multifamily Construction. And with that, I think we'll go ahead and just launch into a brief overview of what RC1 Boost is. Some of you are familiar with this product, and some of you may not be, so we'll go ahead and get that rolling here. Can everybody see my screen?
Yeah, I can see it.
Okay.
Should be good.
Yeah. All right, so RC1 Boost, what is it? This is a very simple product that PAC International developed about 8 years ago. Looking at the photo here, we've got a synthetic rubber bushing or damper, we'll call it, with a fastener, and that runs through your resilient, your standard resilient channel attached to your structure. And this is a product designed to improve the performance of resilient channel. So I'll just go real quickly through an overview of this product. We've tested this product on 77 UL fire resistive designs, mostly floor ceilings and some wall assemblies as well, and done quite a bit of acoustical testing on this product. We've got many of you probably have access to our website or have registered for our website. And you have access to all of our tools and resources, and all of our testing for floor ceiling assemblies and walls is available there. If you haven't registered for our website, we recommend that you do, because there's a lot of resources that are at your disposal there. This is a really easy to install product, and I'll show you a quick overview of that here in a second. And this product we keep plenty of this in stock because this is a product that's really useful at overcoming some of the limitations, around using resilient channel, and we'll talk about that in the case study. Works on walls and ceilings, as I mentioned before. We've tested this on 8 of the most common brands of resilient channel, including Clark RC Deluxe. Real quickly on installation. Again, very simple to attach. You just slide this over the edge of your RC at the pre-punched holes. Comes with the provided fastener for wood or for steel construction. We also provide an installation tool. The key part of getting the performance out of this product is making sure you don't over tighten the fastener, and the installation tool slips over your screw gun and allows you to fasten this into the structure at the right tension. Again, 77 UL fire rated fire resistive assemblies so far. Quite a bit on wood floor ceiling assemblies, wood solid joist, I-joist, open web truss, some wall testing, and we have one test on steel open web truss at the moment. We're planning on doing more steel testing for this product as well in the future. Now, why is this important? This is a quote from the International Code Council from 2010, Guidelines for Acoustics, and we use this a lot in our presentations because we kind of find it, I'm kind of incredulous about it every time I read it, but I'll read it out loud and I'll explain why we think this is important. With the current level of performance specified by the building code, a large percentage of people are highly annoyed by noises from their neighbors, leading to reduced quality of life and possibly to negative health effects. And what's interesting about this is that the health effects of noise are typically understated when we talk about how it affects, us physically. There are studies out there that show that health can be negatively affected by noise, and we're trying to trumpet that to everybody out there that hey, we should be paying a lot more attention to this. The other part of this statement I find kind of interesting is that the Code Council, International Code Council, made this statement, and yet they're not. Our code minimums are STC 50 and IIC 50, and quite honestly, that's inadequate. You know, everybody in the acoustics industry, all the acoustical engineers, all of you are familiar with, and architects are familiar with the fact that the code minimum is not enough, and we need to, you know, we need to push that minimum to a higher standard. And that's what we are doing in this industry, and we're continuing to try to champion that because, yeah, we need to get these levels up to a higher standard. So let's talk about the boost and how it affects performance on RC. And I'm just going to open up all these here. So the first two tests on the top, we have Clark Dietrich RC Deluxe directly to an open web wood truss joist. And you can see the numbers there. The the diagram on the left is that same assembly. By the way, all these assemblies are the same assembly. So we do apples to apples comparison. RC Deluxe with the RC1 boost. And we see some significant gains, specifically in IIC. SDC came up a point, not significant, but our IIC jumped by 5 points. And for a simple product like this and a simple installation, you know, that's pretty significant in our opinion. And furthermore, we also see improvements in the HIIC, which is your high frequency impact insulation class rating, and the LIIC, which is your low frequency impact insulation class rating. If you're not familiar with those standards, these are newer standards that are kind of to break out of the straight IIC rating and give you a little bit more information on, you know, how an assembly performs for high frequency impacts and or low frequency impacts. And you know, in construction, when you're getting into specifics with impact noise, low frequency impact noise, for instance, this can be a valuable rating, and it's you know, they're still working on trying to make that a little bit more clear. It's not an easy rating to measure. But again, just looking at the numbers here for a simple product like Boost, you know, plus 5 points, we think is a good value for this product. Again, this was RC Deluxe, the top two. The bottom two were the Philips RC1 True 25. And again, we've seen some significant improvement in IIC, plus 5 points overall. HIC plus 1, LIIC at plus 4. You know, again, that's self-explanatory right there. Now, what's interesting about this, and I'll just point this out, is that, and this is going to lead into the case study that we're going to talk about in a minute. We've brought up Philips RC1 here, again, what we'll call generic RC1, because again, Clark Dietrich RC Deluxe is the performance standard for RC in terms of, you know, in terms of testing, in terms of performance on most assemblies. That's the go-to for most architects as a spec, and that leads us into some other issues that we'll talk about in the case study. But we brought Philips RC1 up here to the same performance level, or very close to the performance level of the Clark RC Deluxe by itself on the structure. In fact, we beat it by 2 points on the IIC. If you look at the diagonal here of the two tests. So again, you know, this one of the reasons that the RC1 boost is you know, so effective is that we can bring up a lot of different brands to the same level of Clark RC Deluxe if it was standalone on the structure, and that can create some real savings. Real quickly on this slide here, we have International Code Council Guidelines on Acoustics 2010, different levels of what we call acceptable performance and preferred performance. Code minimum, I'll call it inadequate performance, what they call the minimum. Looking to the right on this page here, if you look at that small chart, RC1 directly on the structure, SDC 59, we're just below a grade A in terms of performance. But I think what's more illuminating is our IIC is only at a 52. So, you know, why that's important for designers and acoustical engineers, for everybody here. You know, if we're designing with RC1 directly on the structure, and we're only getting an IIC 52 in a laboratory tested assembly, what are we going to end up with in the field? And most likely we're going to be below code when we get that installed in the field. So, you know, again, the goal here of trying to champion higher ratings is to give us some cushion so that we know we're going to lose something in the field. And so I think that's key looking at that here. If we take the RC1 boost, the RC1 boost plus the RC1, our SDC, we're at preferred performance grade A. And more importantly, our IIC has jumped up to 57. So now we've got 7 points over code minimum. And that makes me a lot more comfortable if I'm designing with a 57, knowing that I'm going to lose something in the field and still be above code, hopefully, when I get into the field, if everything goes correctly. RC Deluxe, you know, straight to the structure, SDC 59, we're at preferred performance, acceptable performance for IIC. If we add the boost to that, now we've got the Clark RC Deluxe to an SGC 60 and an IIC 60. So now we're at preferred performance on RC Deluxe, 10 points over code. That's significant. The last slide here, I want to talk a little bit about cost, because obviously cost is always a question and is always something that's going to determine how we approach an assembly. Base assembly, IIC 50, if we add the RC1 boost, that 5-point gain in IIC, again, IIC 60 has cost us 17 cents a square foot. This is material cost only, by the way, this is comparison. And you saw how simple this one is to install. Now, how do we do it if we don't use something like the RC1 boost? Common methods of improving IIC performance, alternatives to the RC1 boost would be add more bat insulation. So add another layer of bat. That's costing us 62 cents a square foot for material only. And you know, now you're looking at over three times the cost of the RC1 boost, and you've only picked up 3 IIC points over the original assembly. Alternative to that, add another layer of drywall on the first layer, 47 cents a square foot for material cost. We've only gained 2 points of IIC here for a second layer of drywall. And if we factor in labor, you know, for adding more bat, or even worse, adding more drywall, now you're looking at a much more significant difference in cost. And, you know, again, to me, this is a slam dunk, and, you know, people out there who are using this would agree with that. So anyway, that's a basic overview of the RC1 boost. If people have more questions about this product, we can talk about it more at the end of this after we talk about the case study with Zach and Nick. But this just to give you an overview of what this product is. And this is going to take us into the case study, which I'll open up here for you guys. Can everybody see my screen still? Mike, I think you're muted there. Yeah. Okay. Yeah, so this is a case study document that we created, and I'm not going to read any of this, but what we're going to do is we're going to go ahead and open up this up to both Zach and Nick, and have them talk a little bit about, you know, how they came to find the RC1 boost and what it did for them. Zach, if you want to start it off and just kind of give everybody an overview of this particular project, the Nobel Ballantine project, and a little bit about Crescent Communities.
Yeah,
and Zach, go ahead and introduce yourself too, and just your role with Crescent Communities.
Thank you, Mike.
A little bit about who you are, what you do with Crescent, what Crescent does, and then kind of talk about this specific project, if you don't mind.
Yeah, so I work for Crescent Communities in-house builder, Crescent Communities Construction. I'm the project manager on the Novel Ballantine project. And kind of the situation that unfolded out here with our RC1 boost clips was we could not get RC Deluxe due to product availability. So we made the swap early on in the project to use RC1 with the boost clips to maintain the acoustical performance and compatibility with UL. So whenever we got around to inspection time, our fourth floor inspection on the first building had the boost clips installed, and the inspector's interpretation was that only one resilient channel section could apply on the UL, although the boost clips were noted as optional. So I got on the phone with customer support over at PAC, and they helped us out coordinating with UL to get the letter we needed for the inspector to sign off and allow us to keep moving. So everything was compatible. We got what we needed to keep moving in the field, and PAC helped us minimize the time lost with him holding us up on our inspection. So we got moving within the week and did everything they needed to keep us moving.
Yeah, awesome. Thanks, Zach. Nick, do you want to go ahead and introduce yourself too, and kind of who you are, who you work for, and what your role was on this project?
Sure thing. My name is Nick Block. I am a senior engineer with SLR, and we are a global environmental consulting firm. So we have lots of different services that we offer, but here in our Houston office, we are primarily acoustics, and we have a couple of other people spread out across the US and globally as well. I did all the acoustical consulting for this Crescent job and all their projects nationwide. So we have a good relationship and try and keep the standards consistent throughout all the different building types and the different market types that they work in.
Yeah, okay, thanks, Nick. So, Zach, you said that RC Deluxe was the original sort of basis of design, and Nick, can you maybe tell us a little bit about how you, like what, the base of design was for the floor ceiling assemblies here, and kind of how you and Crescent arrived at that basis of design, what the different, thoughts were that went into it in terms of acoustical performance, cost, constructability, all of those items.
Yeah, so this was a wood frame project, and the assembly was a fairly standard multifamily assembly that you see in building types like this, which is using Acoustimet 2 or now Acoustimet 1/4 inch or an equivalent of that product under 1 inch of gypcrete with an open web truss assembly, and then the RC Deluxe on the bottom. And in this case, as I'm sure many others have seen, product availability has been rather horrible for the past year or two, especially when it comes to resilient channels. And the reality is that with the patent that they have or possibly had, that Clark-Dietrich RC Deluxe is really the only name brand option out there for that type of resilient channel that is actually higher performing. And as we've seen, I'm sure many others have seen through testing, a lot of these other resilient channel products are vastly inferior. And we've been seeing substitution requests because of pricing come through a lot more frequently. So, we'll see like a basic Semco RC1 or other kind of similar lower grade resilient channels substituted in by contractors on the projects. In this case, since RC Deluxe is the basis of design, and we know that we can reach in the low to mid 50s with ISC ratings with that product. Since it was unavailable, you're really only left with either, in this case, obviously with RC1 boost, which is a great option, but going to something like a RSIC or a Genie clip in this kind of project, it can get rather expensive rather fast, and that's kind of an overkill level of upgrades for multifamily. It's only really seen when you're around amenity spaces. Those kind of areas can get the upgraded ceilings from products like that. So really you're left with RC Deluxe, either doing that or the RC1 boost on a generic RC, or Semco does actually have a knockoff of the RC Deluxe now. But there is very limited testing information on that, and we haven't really been able to test that in the field yet. So there's not really that many places to go, and luckily Pack International came up with this product. My personal concerns with this product were really just the installation, but Mike can probably delve into the spiel he gave me on that with a contractor of theirs with how easy this was to install. So it's good to see this product getting out in the field and being installed and actually working. So I'm really happy with how all this went.
That's great.
Yeah, thanks Nick for all that details. I mean, yeah, you talked about installation. I'm curious, Zach, what your and your team's experience was with the installation of this. I mean, it is an additional step for installing the resilient channel. Granted, we've tried to make that as easy as possible. And this was a new product for y'all, right? This was your first time working with the boost. Is that correct?
Yeah, that's correct. I think it's actually our trade partner's first time using it as well.
Okay.
Overall, with the difference in cost between RC Deluxe and the RC1 with boost clip, I think even with the added labor, we saved a little bit on this.
Oh, really? So, okay.
Overall, it's not that much more labor. I think the Only item we've struggled with a little bit is the screw holes. Whenever you have to pop them out, it leaves the little rubber nuggets all over the units. But other than that, I mean, it's been pretty seamless for us.
Well, good. That's good to hear. And I think with anything, like we've got some other contractors. We've got one out at East that's used, done hundreds of thousands of these now. They've been using them for years, and it's, like anything, as you get used to it, you kind of understand how to do it. You get into a rhythm with it, and the installation goes a little bit faster. But it's good to hear that initially it was still pretty easy to do. And the cost comparison between sort of generic RC and Boost versus RC Deluxe is something we've talked a lot about here internally. We've really kind of decided not to make those comparisons because pricing can vary so much regionally and even just day to day, especially with material prices now. But it's interesting to hear that even with the additional labor, the Boost Plus RC came out the same or a little cheaper than RC Deluxe for this project.
Yeah, like you mentioned, that's all variable. I mean, this time last year, no telling where the market was compared to now. So I don't know that that's necessarily a standard, but that's what we saw on our buyout.
Yeah. Okay. Well, and with the product availability for the Deluxe, is that something that, I mean, Nick mentioned he's seen it on other projects. Is that something that you're running into a fair bit, Zach, where you're not able to get it or not able to get enough of it? Like we've talked to some of our drywall distributors that we work with. They said they've been on allocation for it. Is that something you're running into regularly, or is this kind of just a one-off situation?
So it seems like a one-off situation to me. I actually had a conversation with our drywall trade the other day that asked if they could switch back to the Deluxe because it was available and costs were coming down on it. So I don't think it's been a recurring thing for me, but it's nice to be able to address the issues as they come up and have an alternate available.
Yeah, certainly. And that's really kind of where we've, that's why we created this boost, is just to create an alternative, because anytime where you have a single product, that creates issues on a job site, just like you saw here. So, and somebody mentioned in the chat here about, it doesn't look like the boost helps with short circuiting, and that's true. It's not the same level of quality assurance with short circuits that you get from something like the Rizik One, using a sound isolation clip with hat channels. The boost does increase the distance between the gypsum board and your structure, so you're a little less likely to get screws actually embedding into the structure if they use an 1 1/4 screw to attach a gypsum board instead of a 1-inch screw. It does help a little bit, but again, it's not the same level of quality assurance. But like Nick mentioned, a lot of times clips, they're more expensive. You pay for that extra level of quality assurance. And a lot of times on a project, the budget's just not there for that. So we really created the boost as kind of an in-between. And I'm curious, Nick and or Zach, if I'm sure, Nick, you have plenty of thoughts on short circuits and, pros and cons of resilient channel versus clips. I'm just curious if either of y'all have anything you want to say about that, either for this project or just more generally.
Yeah, I mean, we could probably fill up a webinar with 2 hours of everyone griping about resilient channel install. So the short circuiting thing is really the biggest concern, though, that I've been seeing more up in the field. It's something that you would think that over time it'd get a little bit easier to get lots of contractors trained up on using the 1-inch drywall screws, but it really just isn't. It's still an issue that has to be addressed every time, really. And this little bit of extra buffer, I could see it helping with that, but probably not enough. You're not adding a 1/4 inch to that, so I doubt that this will help much with short circuiting issues, but it helps with everything else, so it's good for that.
Yeah, it's a little extra safety margin, right, in terms
Yeah.
of your performance and things like that.
And
Zach,
I will note for this project, it was only on ceilings that was installed with these wood frame buildings. Typically, double stud walls are being used for the demising walls, so the RC doesn't come into play as much.
Okay, yeah, that was something I wanted to ask too, is kind of what your design standard was for the walls too. Zach, from your standpoint on the construction side, with with resilient channel, you know, with either short circuits or different installation issues? I mean, is that something that comes up that you found being an issue, or have your, you know, drywall subs that are doing this able to do it where you get satisfactory installations and you've been able to manage that? Like, how is that working for you in Crescent?
We've had, you know, every trade has issues here and there, but for the most part, it's been smooth sailing for us. You know, I think the biggest issue we've had with these boost clips is overdriving the fasteners, which earlier in your presentation, you guys have a tool that addresses that. So I think that's really the only corrections we've had to make so far. Everything else has been pretty smooth. And Nick is correct that the double stud walls do not get RC channel. The only walls that we do out of RC are the corridors on this project.
Okay, so your corridors are single stud with resilient channel?
Yep, that's correct.
And for those, are you putting the resilient channel on the corridor side or the unit side?
The corridor side.
Okay. Yeah, because often if you're putting the resilient channel on the unit side, then you have to deal with cabinets or mounting other things, and that can be problematic mounting with the resilient channel. But
of course, if you put them on the corridor side, then you have to deal with shear panels most of the time. So
sure, yeah. How do you deal with that for the shear panels?
by having to move it to the inside.
And then how do you deal with cabinets?
By there's a couple of details that have been created over the years for kind of creating putting a piece of sheet metal in between extra resilient channel for the cabinets to then be able to fasten into. There's kind of ways of bolting around that for the cabinet supports or for grab bars for handicapped accessible bathrooms. Yeah, so it's not ideal, and most of the time these will be located in areas where a slight decrease in performance because of that additional support could be marginally acceptable. But you know, either way, it's not ideal. It's better if you can do the staggered stud in the corridors, kind of avoid that issue to begin with.
Yeah,
I think the short answer from the construction side is that's what we've got the framing superintendents for, and we make sure we check all those critical openings before we move on and account for every part and piece in it. So there's always plan coordination between sets. You know, everyone does their best to make everything match up, but at the end of the day, that's why these superintendents are out here, and that's what they're looking for.
Yeah. So since we've gotten into it, so we do have another product, the PAC RCB, that's an isolator to provide an isolated backer for cabinets and other heavier items like that works with resilient channel. And I guess Nick, you and I've been remiss in discussing that one with you. But yeah, we've got that, and we've got test data for it in our database too. So something to consider there. So, excuse me. We've kind of already gotten a little broader here in the conversation. So our intent with this was kind of to, introduce the Boost product, talk about it, and then kind of talk about this particular case study, some of the issues that came up there. And then, since we've got Nick and Zach here, and a lot of other folks here with a lot of experience in this, I wanted to kind of just open it up to a broader conversation. I'll go ahead and unmute everybody here. There's been some questions and things in the in the chat. We can talk about some of those, and just, anybody feel free to kind of jump in and ask questions or anything like that here. And let me go ahead and figure out how to unmute everybody. I'm going to allow mics, and I'll allow cameras too if anybody wants to jump on camera. By no means do you have to. So yeah, if anybody's got comments or questions, wants to jump in and kind of join the discussion. One thing that Zach talked about a little bit that we didn't go into as much was the UL on this, and I want to touch on that a little bit because there's a question about it. So this open web truss design, the RC1 Boost, like Steve said, is included in a whole bunch of different 1 hour UL fire rated designs, including a number of different open web truss designs. And in this particular case, the issue that came up with the building inspector was sort of a nuanced reading of the details of the UL assembly. And so Boost is written in as an accessory for use with the mounting of resilient channel. And so typically it can just be used with resilient channel, however the resilient channel is used in that assembly. In this particular instance on this project, I believe that they were using USG's newer Ulix lightweight gypsum board. Is that right, Zach?
That's correct.
Yeah, and in the Open Web Truss assembly specifically, in the UL designs, the Ulix is like its own item for gypsum board, like it's an alternative type of gypsum board. And it references a specific line item for resilient channel that's different from the standard resilient channel. So in like the list of all the different, ceiling support structures, resilient channel might be like item 6. 6A might be like the RISC 1, 6B, 6C, different clips and things like that. And now in like ULL 521, which I think is what they're using here, there's a 6I or something like that is resilient channel that is specific to Ulix gypsum board. And so that was the thing, the building inspector was interpreting it that boost could only be used with the standard resilient channel, not the resilient channel that was specific to Ulix. So that's why they paused the project. So we reached out to UL, got their interpretation that was like, yeah, you can use boost with either of the resilient channels. It's just a broad statement. It's not specific to one listing of the resilient channel. So we got that confirmation from UL so the project could keep moving forwards. And we are in progress right now with UL to get that clarified. And basically it's just, I think, adding an additional statement in that line that says the boost can be used with resilient channel item 6 or 6I or whatever it is. So it's a really simple thing. It's just stating it explicitly instead of implicitly. So that was the issue here. But it's one of those things, we spend a lot of time doing UL assemblies and digging into all of that. So when those issues do come up, we've got an open line of communication with UL, and we can usually get those things resolved fairly quickly, like we did here.
We got a question from Matt Kinch.
Yeah, go ahead.
Yeah, go ahead, Matt.
So I work with Nick over at SLR, and Steve, though, touched on something that we find very important as well, is that even though a design, looks to meet the code minimums by a point or two or what have you, we've done enough field testing of assemblies, and our test results indicate that our field tests might be anywhere from an IIC 43, 44 up to a 46 with just sort of standard assemblies. And so anything to get us that little bit of extra buffer so that if we do get into a field situation where local code official says, okay, prove it to me that you've met your code minimums, we feel comfortable with the RC boost or other strategies to ensure we have that buffer so we're meeting code minimums at all locations.
Yeah, exactly. And that's really kind of like one of the ways that I've thought about the boost is, some extra safety margin, right? Because we know that there's going to be things in the field that affect our performance. I mean, they're going to be, flanking paths and can lights in the ceilings and all of these other things that, it's like nobody's fault. They just are the reality of trying to build buildings. And so having that extra buffer, so you're several, points above code to make sure that in the field you actually meet that, what is it now, NNIC and NISR 45 minimum in the field. Make sure you have that. So yeah, and the boost is an affordable way of doing that. Any other questions or comments?
Mike, we had a question from Bruce Poteet. What is the difference between RC1 Deluxe or Clark Dietrich RC1 Deluxe and RC1?
Yeah, so and Nick, you can and others can chime in on this one too. So RC Deluxe is a specific design that's been around for many years. I think going back to the 60s or something like that. And it has a large dog bone shaped hole in the sort of the diagonal flange between the mounting flange to the structure and the mounting flange for the gypsum board. And so that large dog bone makes that sort of diagonal more flexible. And that's, my idea, my theory is that allows more flexibility and you get more dissipation of the sound energy as it travels through. A lot of the other resilient channels have more metal in that diagonal, and so there's more sound transmission through them. They don't isolate as well. And there have been a number of different studies over the years that have, done laboratory acoustical tests comparing RC Deluxe to other resilient channels. I think Jerry Lilly was the first one that I know of. I mean, maybe it was probably like 20 years ago or something. I think that Jerry did that paper comparing RC Deluxe to a couple other types. I know Vinna Clausen has done some studies in the past. They also just presented on it at, I think, NoiseCon last year. And then Ben Schaefer at Quiet Rock Pabco Gypsum just did a huge study on a bunch of different walls where he tested 7 or 8 other different resilient channels and saw that they consistently performed lower than RC Deluxe. And we've done testing on floor ceilings assemblies as well, like the ones that Steve showed earlier, where we see that, yeah, those other channels don't perform as well as RC Deluxe. And sometimes, it's a few point difference. Sometimes it might be as much as 8 or 9 points, like Nick mentioned. And it kind of depends on the whole context of the assembly and everything. So the vast majority of acoustical test reports that you'll see for different assemblies use RC Deluxe in that. So in order to get that level of performance, you have to use RC Deluxe. If you use anything else, you're going to get lower results. Nick, anything else you want to add to that, or?
Not really. I think Bruce just asked again if it's the one originally marketed by USG, and yes, it's the USG RC one that then the patent got bought out by Clark Dietrich. So
yeah,
it's that same thing. But yeah, the 8 points, I just saw that, and one of our clients did a whole bunch of lab tests, and they were trying out different finish flooring materials. Really, that's what they wanted to test out. But they used the RC1 from they used RC1 Pro from Clark Dietrich everywhere, and it performed about 8 points lower than the RC Deluxe. And another thing to note is that old marketing materials, as we found out for the RC1 Pro, touted it as being almost the same performance as RC Deluxe. And some materials, they even show it to be about the same IIC rating. And that's kind of propagated through people's memories at this point. So lots of people are convinced that the RC1 Pro is totally equivalent to the RC Deluxe, which it is not.
Yeah, right. Tim, I see you've got a hand up.
Hey, yeah, great presentation, guys. So for my Canadian team, I would ask, can we get a copy of the presentation, and or Mike, can you join us at a future date to relay all this information? Would be appreciated, and nice add with the LIC data to confirm you're also getting contribution and a boost, as they call it, at that low frequency. That's ultra critical. So well done, lads. Thanks.
Yeah, thanks,
Thank you, Tim.
Thanks, Tim. Yeah, so I'm happy to share the presentation with you. Anybody else? We'll also put the recording up too. There's a webinars section on our webpage where we've got recordings of past webinars. We'll put this up there as well. I can send you the PowerPoint presentation. The test data is available online if you want to go register. I put the link in the chat earlier. We can add that again. And yeah, Tim, happy to talk with you and the Canadian team as well. And I think I saw a couple of people ask about product availability in Canada. You can always buy from us and ship there. I think we have maybe 1 or 2 distributors up in Canada right now, but it's something that we're working on getting more distribution set up in Canada. And the Boost is one of the products that we're specifically looking at getting into that market more.
Yeah, we're still working on some agreements in that area for Canada nationwide distribution. We're not there yet,
but it's something we're actively working on. So hopefully we'll get there soon. Yeah.
There's another question, Mike, from Yvonne de Hamel. How would you compare in price RC Deluxe plus Boost versus RISC 1 or the RSIC 1 sound clip?
Oh, so RC Deluxe plus Boost versus the RISC 1. That's a good question. And
we haven't done a cost analysis of that, but
yeah, and Zach, you might even, like, if you used clips, either the RISC 1 or other clips for that matter, on projects like for amenity spaces like Nick mentioned, you might even have a better idea of like real world pricing for that. I mean, my assumption is that the RISC clips and hat channel will be more expensive and by a decent margin than RC Deluxe and Boost, because I think hat channel itself is the same or more than like RC Deluxe, and then the clips are more than the boost. So there's definitely a price difference there. One thing to keep in mind is the boost, when you're installing it per the UL Fire designs, you use a boost isolator at every point that you're fastening the resilient channel to your structure. So it's usually going to be 16 inches by 24 inches on center. Either your structure is 16 and your resilient channel is 24, or your structure is 24 and your resilient channel is 16. With clips, you're typically at 24 by 48, or usually 16 by 48 for fire rated assemblies for floor ceilings. So you're using fewer clips of the RISC 1 than you are the boost. You know, but the advantage of the RISC 1 is the lack of short circuits, that quality assurance, like we've been talking about. Zach, do you have any kind of rough idea of the cost comparison between those from any projects where you've used them both, or just RC Deluxe versus clips?
I don't specifically. I think I agree with your train of thought there. My trade partners are a little more in tune with the current market, but I do feel that the clips and Deluxe would be the more cost-effective route, but that's just a hunch for me. I would have to do some research to get some more information on that.
Yeah, I think that's probably the case. And Nick, you mentioned using clips at amenity spaces and things like that. That's kind of one thing I wanted to touch on is, you know, here we've talked about sort of your standard design for the floor ceiling assemblies between units and also wall designs. But in these projects, are there places where you do something different, like amenity spaces, gyms, or any other areas?
Yeah, it kind of depends on how everything's constructed. Most of the time, we're lucky enough to have a podium slab above amenities. In that case, that really goes a long way to mitigating a lot of these issues. Then you can kind of do a drop ceiling, and most of your amenity woes are kind of attenuated enough by that with an 8-inch slab, or in most cases with the podium slab, you're getting 12 to 15 inches. And that helps a lot. Special cases like theaters, obviously you'll have full-blown suspended spring or neoprene isolated ceilings, depending on what the configuration is. With concrete, normally neoprene's good enough, and then for wood framing, you have to do those the kinetic product. I don't know why I'm drawing a blank on it right now, but it attaches to the side of the truss and has a spring isolator on it.
Or the pack version.
Or the pack version, yeah. Trying to keep things neutral. Okay.
Yeah, no, you're good. A 1-inch deflection spring isolator. We'll say that, right?
I'll say that. Yeah.
Generic.
Yeah. So that you have the additional low frequency isolation. Yeah.
Yeah. Although maybe you can show me some data to prove otherwise. I would think that the clip option for something like a theater where you have subs with wood framing, to me that would not be enough isolation. Maybe a Quiet Rock. I could be convinced, but yeah, let me know if you have some data on that, because that would be interesting to see. But normally we've had some areas that are like kind of open for town hall kind of areas, other discussion areas with like small loudspeaker setups, and in those cases, that's where your RSIC type product can come into play and is rather useful. But most of the time for these, we don't really have to elevate to that level for the type of amenities that are going in these buildings. A lot of them are kind of club rooms and stuff like that.
Okay. What about fitness facilities? Are you fortunate enough where most of those are located on the ground floor slab on grade, and you have fewer issues with those, or do you have ones that are elevated sometimes?
Sometimes, a lot of times they are elevated, but then it's much more of a flooring isolation exercise than anything else. Most of the time, if they're elevated, they'll be on a luckily normally then it's a concrete building, and they're putting them up on the top level, up on level 40 something. And obviously it requires a lot of slab isolation, but not necessarily that much from the clip side. Although actually that does bring up a good point for those. We will normally incorporate RSIC or an alternative for the units below, where you have a pool deck or any other amenity deck on the rooftop level, or any other really rooftop amenity, normally having clips with 2 layers of chip on the underside helps a lot with isolation for those types of setups.
Yeah, that was my experience, consulting here in Portland. I did a lot of like, wood framed 5/1, 5 floors of stick frame on a podium slab. And here, just about every apartment building I worked on, they had a rooftop amenity space. There's an indoor area and then an outdoor area, and those would always be over units. And so, for the most part, our floor ceiling assemblies, the ceiling was isolated with resilient channel because of cost. But then it was in those amenity spaces where we'd have larger gatherings of people, more activity and things like that. We would usually do clips on those places for that extra level of isolation and better quality assurance too for the field performance.
Sure.
Yeah, on the comparison between clips and springs, that's something that I'm hoping to dig into this year. And especially for like I think that the comparison will be different between concrete assemblies and like lightweight wood framed assemblies. And one of the things that I want to try and figure out how to look into is for a lightweight wood frame structure, right? You've got sort of, as I'm thinking about it, 2 transmission paths. You've got for impact or airborne sound, really. You've got a structural transmission path through your joist, your truss, or whatever, that then gets down and excites your ceiling and is re-radiated. But then you also have a cavity transmission path that's through your subfloor, through the cavity, and then through your ceiling. Your ceiling isolators, whether it's resilient channel, it's clips, or springs, isolate that structure-borne path, but they don't really do anything for the cavity path besides maybe slightly changing the sort of the effective stiffness of that gypsum board layer and its modal response or whatever. So what is the break point for the isolators at which a certain isolator gives you enough isolation of that structural borne path where that cavity path becomes dominant, so that getting additional isolation doesn't actually give you any more performance, right? And so if you have a very lightweight, wood structure, maybe a retrofit situation where you've got, a 2-layer plywood subfloor or something like that, or a subfloor with wood flooring on top of it, and you're doing a 2-layer gyp ceiling, like, I don't know if springs really give you a benefit in that over clips because you've got so much cavity transmission. But if you're doing a robust, 1 inch or 1.5 inches of gypsum concrete on a thicker mat, like maybe you do get enough of that where you'll still see a difference in performance between springs and clips. I'm not sure. And it's difficult to test, especially for airborne sound, because even with resilient channel and like boost, you see for these assemblies, STC ratings are 60 and higher. The laboratory flanking limits for most of the labs for airborne sound is STC 65 or thereabouts. And that's the maximum that they can test. So if you're still 5 points below that, you're still being affected by the laboratory flanking. So it's very hard to distinguish the airborne sound isolation of different products when even basic resilient channel gets you close to the lab's limits. You can distinguish differences for impact sound, but at a certain point, you may still run into laboratory flanking issues there. So that's made that line of investigation much more challenging.
We have another question from Ben Seep. Any experience with wall-mounted TVs on a wall with RC1 boost? Could you use the RCB to isolate a backer for the TV? Could that be sufficient for something like a hotel wall?
Yeah, I think the RCB, we haven't done testing of the RCB with TVs. We actually have tested our RISC 1 backer on a RISC 1 wall with TVs, and I can't remember if I have all of that data. We didn't, I think, get formal test reports for that, so I'm not sure if I have it in the database or not. I think it's there now. But we actually have some data there where you can look at the differences in sound transmission for the TVs mounted on the wall. But I think mounting a TV with the RCB on an RC channel wall would certainly help, because it's going to reduce that structural transmission from the TV and also just maintain the isolation of the resilient channel. And I think for a hotel wall, I mean, what is sufficient is going to depend on the expectations for that hotel and the clientele. Are we talking about a budget motel, or are we talking about like a Waldorf Astoria, right? So what's sufficient is kind of difficult to to determine, but it will certainly be a lot better than just mounting the TV the other ways with Brazilian channel. Nick or anybody else on here, I'm curious, like your experience with TV for walls and hotels and things like that.
I don't really touch hotels too much, so I haven't had very much experience with that one.
Okay.
Multifamily, we generally just avoid it.
Yeah, right. Yeah, and you have a little bit more leeway there. And if you're using, you know, double stud for your walls, then you've got that structural decoupling anyways.
Exactly.
So, speaking of TVs, this is Joe Morris. Any potential for PAC to get into acoustically rated display back boxes? Currently, my only option is fire putty pads on the back of the back boxes. Maybe. I mean, I don't know if you've seen our whole product catalog, but there's a whole lot of options in there, and a lot of them came from questions like this. So let's chat more, Joe, and see. I mean, we definitely have a lot of other products and stuff in the works right now. You know, Elzo especially is always kicking up new ideas for products. So
yeah, we're always looking for ways to maintain the isolation of our our primary products. With
yeah,
associated products that are going to address things like TVs, cabinets, things like that.
Yeah, we're trying to focus as much on like the real world of how things are actually built, to make sure that they work not just in a lab but in the real world, and they work with acoustics but also fire, constructability, all of those kinds of things. And yeah, Tim, you said slab on grade can be a devious one too, and you're right. You can still, especially for heavyweight impact for gyms and things, you can still get a fair bit of transmission up through the structure, or even laterally to adjacent spaces. I've had as issues. So it's certainly usually better than an elevated, but it's not a panacea, I guess. Yeah. So fair point there. Yeah, any other questions?
Questions, comments? Guess not. We're at the hour 9 mark here. I hope if there's any other questions, I think we're probably wrap this up.
Yeah, we can wrap up. If anybody else has questions, I'm happy to stay on. Zach and Nick, I really appreciate y'all taking time out to join us.
Thank you both.
And to chime in on this. It's great to have your input.
Yeah, we really appreciate the participation and the case study. Really helpful.
Yeah, thank you guys for putting it together and for inviting us to the call.
Yeah.
Thank you. Happy to help.
All right.
Thanks so much.
Okay. Everybody have a great day.
Yeah, everybody have a great day. Y'all take care.
Take care.
Do the same. Thank you.
See ya.
Bye-bye.